Okay, so, all right, for those at home, if you have any questions, don't be afraid to answer, or ask, I should say. Throw out stuff as we go through class. Just think of it like a normal day. New thing today, we're going to be talking about systems. I really haven't explained that word to you yet. A system of equations is where you are comparing two equations, stacking two equations on top of each other, and you are trying to find the common solution between them. Okay, that's what a system is. It's where, two equations have the same answer, and you're trying to find the one answer that they share. Well, it's the same concept of having two equations and finding that point of intersection. That's a system. Two equations being compared. They have the same variables. They have at least one solution that they share. So that's what we're going to look at today. We're going to look at just single solution problems. Maybe later this week we'll look at special cases. But for right now, I want to introduce a new method today. We've done graphing. That was the stuff we did last week. I think we had an assignment due Friday last week on graphing. You had to do that. We have an assignment due tomorrow on elimination method, where you stack them and you add as long as your variables match. But we have a new method, and it's called substitution method. Here it is. This is the method we're going to be looking at today. I think it's pretty easy. In fact, some Algebra 1 students actually prefer this method compared to the other methods I've shown. Some people don't like graphing. It's not just the idea of, it's not an exact, science to it. You have to kind of give it a little wiggle room. You have to kind of interpret the graph. Some people don't like elimination. There's too many weird rules that you have to remember, and some people just don't like that. I'll review an elimination problem today. That'll be one of our last ones we look at. But I want to talk about substitution. It requires that you just know some simple Algebra 1, and it will work every time. So let me get you started here. Let's talk about an example. So first example of the day: 3x minus 2y is equal to 0, and x is equal to 2y minus 4. So these are my two equations. Definitely not in the right form from yesterday. The top one is, but not the second one. So the elimination process, we don't want to do that. We want to do this new substitution method. So this is kind of our goal today, is to learn this. Now, why you'd ever choose a different method? Obviously, people are really good at graphing. You have graphing paper, maybe you want to graph. Elimination method is my go-to method. I prefer elimination method. I like it. It works for me. I'm pretty quick at it. But this is a different method. If you're really strong at Algebra 1, solving for x, solving for y, this might actually be the method for you. It just requires to understand that simple word, substitution. That's really what it requires. If you can substitute or replace of equal value, this is kind of your method then. So how do you know when you should do one versus the other? It really doesn't matter. You could do any method. They'll get you to the same answers. It's not like having a different method would give you a different answer. It doesn't. It gives you the same answer as the other methods. I'll prove that with my last one I'll do today. I'll do the last example, and I'll show you that it will work no matter which method you choose. But I want to show you this new method. So why you'd ever choose this substitution versus elimination? It's when they have suddenly put one variable by itself. So on one of your equations. So like if you look at my two equations I provided you here, does one of the two equations have a letter that's by itself?
Yeah.
Which one? Second one, right? Right here. The x is by itself. Agreed? There's no number in front of it, nothing. It's by itself. That's when you should do this method. Right there. That's when you should recognize it. If it's not in this format, you might need to rearrange it, and that might be maybe the third example I show you today, where we have to rearrange a little bit. But what this is saying is anytime you see an x, it is equal to 2y minus 4. That's what it's saying. You're going to replace all x's in a problem with a 2y minus 4. So I want to show you that. I want to show you this idea of substituting. So I'm going to take the x out of the top equation. This is the top equation. I'm going to take the x off of it and replace what x is equal to. So in the second equation, what was x supposed to be replaced by? 2y minus 4. That's substituting. I'm substituting something of equal value into the other equation. I took one equation and plugged it into the other one. You have to plug from one to the other. And it'll work. It'll actually solve. You only have one variable. If you look at this equation, there's only one answer. And we're going to solve it. But again, it requires that you have very, very, very strong Algebra 1 skills. So if your Algebra 1 is lacking, maybe not the method for you. Let's continue. So if I was doing this problem like a normal Algebra 1 problem, what would I do next? Yeah, you're absolutely right. Just distribute the 3 through the parenthesis, right? You're going to multiply it through. That's what I'm going to do. I'm going to do the same work that you just thought of, right? Taking 3 times the 2y, that's 6y. Taking 3 times that -4, that's -12. And then I have that minus 2y back here, and then I have that equals 0, right? And you only multiply the 3 into the parenthesis. If there was a 1 out there, fine, multiply a 1 through the parenthesis. If it was a negative, fine, multiply the negative through. I don't have that, so that's what I did. And now I'm going to solve for y. So is there any like terms I can combine on this left side? Yeah, the y's. I can combine those, right? So I can add. Let's turn off the Wi-Fi. I'm going to combine the y's together. So 6y minus 2y, that makes 4y's. Right, I can combine those, 6 and a -2, right? And then I'm going to move the 12 across and solve, right? The 12 doesn't have a y in it, so I'm not going to add it to the 4. So I'm going to add the 12 across. So moving that over, it becomes positive, right? And then what do I do next? Yeah, divide, right? Divide by 4. Divide by 4 to both sides, and my y ends up being a 3. I just found one of my answers. Like, that was the whole point, right? That's what we did all day yesterday, is like, find your answer. Find that coordinate where they crossed each other. We're solving a system. A system is 2 equations where they have one common solution. All right, now, just like yesterday, think about this. Yesterday we did, elimination. We did graphing the day before. But what do we do with that 3? Plug it in. It's the same steps we did yesterday. So it's very, very, very similar. So I'm going to just take that 3 for the y and plug it back into one of the top equations. Guess which one you should plug it into? No. Plug it into the one I circled. The one that I put the bubble around. The one that you substituted into the other one. That's the one you want to plug into because you won't have to do any rearranging. So I'm going to take my y is a 3, and I'm going to plug it in. So I'm going to take this is the second equation, that's the one I plugged into the other one, right? The part I circled. And I'm going to plug the 3 into the y location. And then I'm going to solve. So this ends up being 6 minus 4, and what does my x equal? 2. Done. That's substitution. Question?
But when I did the top equation, I got the same answer.
Oh, yeah, they work the same. Yes. So good question. So if you didn't hear Skylar here, he was asking, well, I plugged the 3 in the top equation. Yeah, that's the beauty of doing these. It's the beauty of doing elimination. It didn't actually matter which one you plugged it into. I would recommend plugging it into the top, the second one, the one that I circled. The reason why it's easier, I didn't have to rearrange. But yes, I agree. If you plugged it into the other one, it would still work. That's the beauty of doing systems. The solutions we get are the same no matter which equation you choose. So, but yeah, so if you want to choose the top one every time, you do you. So, all right. Questions on the first one? That was good. I like that. Okay, let's do another one. Same exact way. Then I want to show you the elimination method that we did yesterday. The stuff that's doing the homework tomorrow, right? I do want to remind you of that. I don't want you just to turn you loose and then you're all confused and you're discombobulated about what we did today and what we did yesterday, and now you're confused on which method you should do and you don't even remember yesterday's. So I want to remind you of how to do that so you're not lost. So let's try another one here. Let's do one more and then we'll do that elimination method, the stuff we did yesterday. So I want to refresh your memory, show you that it will work. All right, so second equation here. Here we go. It is, let's go 2x minus y is equal to 15, and y is equal to x minus 8. So different equations. That's my second equation here. We're looking for a solution that works for both equations. This is a system. They have the same variables. It's two equations. Now, should we do substitution or should we do elimination?
Substitution.
Yes, why?
Because the y is by itself on the second one.
Exactly. That's why you should recognize when to do one versus the other. So if you didn't hear that, you should use the substitution method because the y in the second equation is by itself. That's when you should do it. This y is equal to an x minus 8. It's by itself. That's why we choose, whoa, that was a weird arrow. That's why we choose this method, is because the y is by itself, or x is by itself. I'm going to take that and plug it into the other equation for the letter it's supposed to be equal to. So I'm taking that second equation, the x minus 8, and plugging into the y in the top one. So here's the top equation. Draw a line here. I'm going to take out the letter y, wherever it's at, and replace it, because y is the letter that was by itself, so I'm replacing it. So I'm plugging the x minus 8 in. Does that make sense? The top equation took out the letter, plugged in that thing in a parenthesis where it was supposed to be. If there was a number in front of the y, that number would stay there, right? If it was like a 4 in front of the y, then I'd leave a 4 out front of the parenthesis. In my case, I have a negative sign, so I had to leave that there. Okay. So, what do we do next? What do you think?
Go for 2x times the quantity.
No.
I think 1, there's supposed to be a 1, right?
Yes. There is a 1 right there. In fact, it's a negative 1 in front of the parenthesis. You have to distribute it. You have to distribute this negative sign through the parenthesis, the negative 1. So this ends up being a 2x minus 1x plus 8, because it's a negative 1 times 8. Negative 8, I should say. So I'm distributed the negative 1, multiplied it through. Yeah, so again, the 2x wasn't attached. It was the negative sign, the negative 1. That's technically attached. And now we just solve. Add it like terms. 2 minus 1x. Yeah, well, it's 1x, so we have that plus 8. The 15, technically, I don't even need to write 1. I mean, you could leave the 1 off and it's still the same answer. You just write it like that. 2x minus 1x is x. It's 1x. The 1 is technically there. And what's my last step? What do I have to do? Subtract 8. If I subtract 8 over, right, because you're going to subtract the 8 across the equal sign, I get 7. There's my x. Seven is my x number. And then I would plug it back in. Now, just like we were talking about earlier, it doesn't actually matter which one you plug it into. I just recommend that you plug it into the one that I circled, the one that I put the bubble, because I don't have to do any weird rearranging. It just kind of works. Plugging that back in, here's the equation that I circled earlier. I'm going to plug my 7 back in, and for x. And so 7 minus 8, what is that, a negative 1? And that's your y number. So that's the answer we're looking for. All right. Okay, questions for anyone at home or in here? Anything that you're not quite getting? Maybe I'm going too fast. I don't know. It's hard to judge. I can't see faces, so I use facial expressions a lot to kind of judge and get a sense of empathy for you if you're getting lost or you're confused or can't read facial expressions right now. All right, I want to do another one, but I want to show you that elimination method, the method we did yesterday. I think it's important that we review that. Why you choose to do it, when you would choose that versus not. That's what I want to talk about. Okay? All right. So let's go to the second. Let's go to the third problem here. So, okay, I'll rewrite this. So here's the third example. We have x plus y is equal to -1, and then I have a 2y plus x is equal to -6. All right. Now, I've already kind of hinted at this. You don't have to do substitution on this method. You don't have to do substitution on any of these. Maybe that's a method that's just too much for you. You could go back to the elimination method. In fact, I almost recommend the elimination method on this problem. You don't have to. I can do the substitution. I'll just have to like solve for a variable, get a letter by itself, and I'll show you that here in a minute. But I would probably say on this problem, it would actually be just smarter to do the elimination method, the method we had yesterday, just because it's almost in the right format. It's almost in, standard form, that ax plus by is equal to c. It's almost in that method. I just have to rearrange that second equation, get it kind of rearranged. So that second one, so here's the top equation again. The second equation, I'm just going to move the x and the 2y around. And notice they didn't change negative or anything like that because they didn't move across the equal sign. So now they're in the right format. So that's why I would choose elimination on this one. But you don't have to. So you'll get to see this. I'll do the same problem with substitution and you'll see it does work out to be the same answer. All right. We have to pick a letter. X or Y's? X's, good choice. The reason why you want to pick X's, they're already the same number. Duh, they're already ones. I don't even have to multiply by anything. That's why another reason I would use elimination, because they already match. I don't have to do any crazy work. But I do need to make one of them negative, because one of them has to be a negative X. Which row should I make negative? Bottom, okay, let's do that. So I'm going to make the whole row negative, so that 6 actually turned out to be positive, because it was a negative x, a negative 2y, and a positive 6, because you have to flip all the signs. You only have to do this if one of them isn't negative. Now, when I add straight down, the x's eliminated each other. That's why it's called an elimination method. The 1y and the negative 2y makes a negative 1y, because 1 and negative 2 makes negative 1. And then 6 minus the 1, adding straight down to positive 6 and a negative 1, that makes 5. And how would I solve? Yeah, divide, right? You'd have to divide by the negative 1, divide by negative 1, so it would be y equals a negative 5 out of this thing. So that's what we were doing yesterday. So now this method is, what we're about to do from here on is super similar to what we just talked about today. The substitution method uses the same second steps where once you find a letter, you just plug it back in. And just like what Skylar said earlier, is that it doesn't actually matter which equation you plug it into. It's going to work no matter what. You'll get the same answer. In fact, if you pick the top one versus the second equation, it doesn't matter. Do you want top or bottom? Which one do you want? Top, okay, good choice. I think that's an easier looking equation. Okay, and so I'm going to take my y, plug it in, so it's a negative 5. Plugging that back in, and then just solve, right? So, moving this negative 5 across, I'll make it a positive 5, adding it over. And so my x ends up being what, a 4? And there's my answer. You would have got the same answer if you did the substitution. It'd be the 4, -5. That's the same solution. It would just require different steps. The second one is the same, right? You still plug in your number into whatever variable you want, or whatever equation you want, I should say, not whatever variable, but whatever equation, and then you still solve. So that's similar, but the main step is that you have to like take one equation, plug it into the other equation, right? All right, but I do want to show you that. So this is my last example of the day. This is my last bit of note here. I'm going to do this exact same problem, but I'm going to do it by the other way, so you can see it. So I'm going to do it by substitution. So I'm going to prove that we're going to get 4, -5 here. So no matter which method you do. But again, remember, this is the way we're doing homework. This is the way I expect to see your homework to do tomorrow. I think it's what a worksheet with what? 5 problems, something like that? Is that what it was? 5 problems? Mm-hmm. Okay. There's no graphing, nothing like that. You just have to show the work, show what you're doing. I think I gave you enough time. Just put it on a separate sheet of paper, take a picture, submit on Google Classroom. All right, let's do the same problem. I'm going to write down the exact same steps, but now we're going to do it by the other method, just to show you that it does work. So x plus y is equal to -1, and 2y plus x is equal to -6. So same problem, but now I'm going to commit that we're going to do this by substitution. So substitution method. We're gonna commit to this format. So I need to get one of the variables by itself. So I don't know. You want to rearrange that top one or the second equation? What do you want to do? Top one? Okay, let's do that. I'll move the x over. How about that? Now it seems weird. The top equation. I'm just going to move the x to the other side and make it a -x. So there's that variable that's by itself. That was the top equation, right? I just rearranged it a little bit, move the x over. So now you can do substitution. One of the letters is by itself. I'm going to go to that second equation here, that other equation, which was this one. In fact, I'm going to write it out again. This is the second equation. And I'm going to take out one of the letters and plug in what it should be equal to. Well, what letter am I taking out? The y, yeah. I'm taking out this letter, the letter that you had by itself. So on this second equation here, this is what it's going to look like. You're taking out the variable that was by itself on one of those equations. So, and I'm going to plug in what it was supposed to be equal to. The y is supposed to be on -1 minus x. Again, it didn't actually matter which equation you did. So if you would have rearranged the second equation, you would have just, done the same work. Now, doing the math here, let's multiply. So I'm going to multiply the 2 through, so I get -2 minus 2x plus 1x is equal to -6. I'm going to add those x's together, so combining like terms. What do we have? We have, what is that, -1x. -2 and a 1 makes -1. I'll have to move that 2 across. So if I add the 2 across to the other side, that's -6 plus 2, which is -4. Then dividing both sides by -1, it looks like my x turns out to be a +4. Well, duh, that's what we just found out a little bit ago. All right, that was the last problem I just did. So, duh, we're getting the same numbers. And then just like before, substitution and elimination, they still have that, they share that same rule where once you find a letter, you just plug it back in. And I usually always plug it back into the equation that I had circled. So I'm going to go back to the equation that I circled. That was this one. And I'm going to take out that variable and plug in what number we just found. We just found that x was a 4. So -1 minus 4, which is -5. So, same numbers, same answer. Okay, now, you're probably wondering, okay, what is the Google question of the day? Because I've been doing a Google question every single day. This one's a little bit different today. It's not, okay, which, example am I doing? What's the answer? No. Today, I want you to go on Google's Classroom and answer the question by how would you explain the substitution method to someone? you know, explain it in words. How would you do it? What are, maybe you're going to compare it to the elimination method, how they're similar or different. How you would, you know, explain to somebody that's maybe never seen it before. And just type out a few words. You know, how would you do it? How do you start? Would you show an example of how to do it? You know, just try to type in some, you know, try to give me a good reason. What I'm doing today, I know this seems weird. This is our first practice at really doing what we call race format in here. And I know you're thinking, oh my goodness, you didn't just say that. Yes, I did. We have to do a race format. We have to do one a year. I usually do them on my semester tests. So I always try to start early enough where you get some good practice every week leading up to our semester test, which is the last week in December. So before winter break. So this will be our first adventure, and you know, trying to use your words to explain how to do something, not writing numbers, and you know, so you're actually learning how to do it for math. So that's what I want you to submit today. And that's your Google question of the day. How would you explain how to do this stuff to somebody that's maybe never seen it? So do the best you can. Maybe you want to use an example as your, you know, as your topic. Homework's due tomorrow. You have the rest of class day to work on it. Not a lot of time. You have about 10 minutes, 12 minutes, something like that. For those at home, thank you for tuning in. Make sure you go answer the Google question of the day. I think I got all of your, I think I got all the people logged in, I think. Yep. So thank you for tuning in. You guys can log out, go answer your Google question, go work on your homework. You'll submit your homework on Google Classroom. So unless you have a question, stick around. I can always go through another example. I always have an extra if you need one. So, but yeah, you guys are good to go. So.